Chapter 5.4, Day 1, Solving Radical Equations. Solving equations with radicals that have variables in their radicands are called radical equations. So for example, if you have a square root and inside of the square root you have a variable, that type of equation is called radical equation. Equation means you should have an equal sign. So this has an equal sign. And equation means that you should have a variable, so that has a variable inside the radical symbol. Next is solving radical equations. So what are the steps that you need to solve the radical equations? Step number 1, isolate the radical on one side of the equation if necessary. So in this case, if you have a radical equation, you need to remove the 2 so that you have a radical by itself. Step number 2, raise each side of the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. So in this case, first step, I should remove the 2, and then I would take the square on both sides to remove the square root. So if it is a square root, you take power 2 on both sides. If it is a cube root, you take power 3 on both sides, so that you can remove the radical symbol, and then you can have an equation that is inside the radical symbol. Next step is to solve the resulting equation using techniques you learned in previous chapters, and you're going to check your solution. Now we are going to apply the steps to solve example number 1, letter A. So first thing is that we are going to remove the 2. So 2 should be divided both sides. So divide 2 on both sides. So 2 and 2 cancel. You got here is square root of x plus 1 equals 2. Now the next step is to get rid of the radical symbol. This is a square root symbol. To get rid of the square root symbol, we need to take square on both sides. So we're going to take square on both sides. What this will do is cancel the 2 and square root. You will get here is x plus 1 equals 4. And subtract 1 on both sides, you get x equals 3. Now we have to check if the 3 is the right answer or not. And we're going to use the original equation and plug it in x equals 3 into the original equation. So here are we going to check 2 square root x plus 1 equals 4. Where you're going to put x as 3. So this x value, you're going to plug it in here. And what you get here is 2 times square root 4. And we know that square root of 4 is 2. So this is going to be 2 times 2. 2 times 2 equals 4. So 4 equals 4, which is true. So our checking part is complete here. Now we are going to do letter B, where I can see that this part is a radical that should be by itself. It means that we need to remove this 1. To remove this 1, we are going to add 1 on both sides. So what you got here is cube root of 2x minus 9 equals 3. Now to get rid of the cube root, we need a cube on both sides. So we are going to take cube on both sides. So 3 and 1 of 3 cancel. You got 2x minus 9 equals 27. You're going to add 9 on both sides. You get here 2x equals 36. You divide 2 on both sides. You got x equals 18. So x equals 18 is your answer. But we have to do the checking part right here. So for checking part, we are going to use the x value and plug it in into the given equation. So here x value, we're going to plug it in as 18. So cube root of 2 times 18 minus 9 minus 1 equals 2. So here we got here is 36 minus 9 minus 1 equals 2. 36 minus 9 is 27. And cube root of 27 is 3. So 3 minus 1 equals 2. 3 minus 1 is 2. So 2 equals 2, which is true. Next, we are going to do the U-try problems, number 1 and number 2. For the U-try problem number 1, you're going to isolate the radical. So you're going to add 9 on both sides. You got here is negative 6 plus 9, that is 3. You need to get rid of the cube root, so you're going to power it by 3 on both sides. 3 and cube root cancel. You got x equals 27. Now you're going to check your solution. So you're going to use the original equation. And here for x value, you're going to use 27. Cube root of 27 is 3. And 3 minus 9 is negative 6. So which is true. For number 2, you're going to take a square on both sides so that you can get rid of the square root. X plus 25 is going to be 4 minus 25 on both sides. You got x values equals negative 21. That value you're going to choose or use actually and plug it in into the main equation to see if the two sides are equal. So you got square root of 4 equals 2. So this is 2 equals 2, which is true. Next is question number 3. For question number 3, you're going to get rid of the 2 to get the radical by itself. And then you're going to take cube on both sides so that cube root and cube cancel. X minus 3 equals 8 plus 3 on both sides. You get x equals 11. Now you're going to use this x equals 11 and plug it in here to check the solution. So you're going to get here is 2 times cube root of 11 minus 3. And 2 times cube root of 8. Cube root of 8 is 2, so 2 times 2 is 4. 4 equals 4 is true. So your checking part is complete and your solution is x equals 11. Raising each side of an equation to the same exponent may introduce solutions that are not solutions of the original equation. These solutions are called extraneous solutions. When you use this procedure, you should always check each apparent solution in the original equation. Now we are going to do example number 3, solving an equation with extraneous solution. We are going to solve x plus 1 equals 7x plus 15. We're going to get rid of the square root, so it means that we're going to take square on both sides. So x plus 1 square equals square root of 7x plus 15 whole square. So square root and square cancel. In this side you have x plus 1 times x plus 1. And this side you will have 7x plus 15. This side you have to work and solve to get the equation. So in order to solve two polynomial multiplication, we can use the FOIL. So you got x squared plus x and plus x plus 1 equals 7x plus 15. X squared plus 2x plus 1 equals 7x plus 15. Now we are going to make this as one equation. So you're going to bring this 7x plus 15 onto this side. So you're going to subtract 7x on both sides and 15 on both sides. So what you got here is going to be a new equation, and that equation is x squared minus 5x minus 14 equals 0. So this is your equation that you need to solve for x. This is a quadratic equation. So to solve quadratic equation, you learned few ways, and one of the famous way is factoring. Factoring, where you make a cross. On the top of the cross, you have a number that is negative 14. On the bottom is negative 5. You're looking for two values. When you multiply these two, you get negative 14, and when you add them, you get negative 5. So you're going to use this cross to find out what are those two values. And those two values are going to be negative 7 times 2. So negative 7 times 2 is negative 14, and negative 7 plus 2 is negative 5. So the two factors are going to be x minus 7, x plus 2 equals 0. Now we're going to use the zero product property to solve for x, and x is equals 7, or x equals negative 2. Now we have two values. When we square, it always gives us two values, but some of them, or sometimes one of the x values is extraneous solution, means not a valid solution. So we have to check both the x values by plugging it into the given equation. And that's the most important step for this type of equations. First, we're going to check x equals 7 and see if that is our solution. So I use the x value equals 7, and I put that into the given equation. X equals 7 for x value here. So you got here in 7 plus 1, that is equal to 8. This way you're going to get 7 times 7 plus 15, that is 49 plus 15, that's 64. Square root of 64 is 8, so 8 equals 8 is true. So this is our solution. This is our solution. Now we're going to check if x equals negative 2 is our solution or not. Choose the original equation again and use x equals negative 2 for x value. Here you got negative 2 plus 1, that is negative 1. 7 times negative 2 plus 15 is negative 14 plus 15, that is square root of 1. Square root of 1 is 1, but on the other side you have negative 1. So which means that this is false, this is not true. And that means that x equals negative 2 is not our solution. Next, we are going to use the you try problem to see if we have understand the topic. To solve the next question, we are going to take a square on both sides to get rid of the square root, and we are going to do the FOIL on one side. So 10x plus 9, and this side you're going to have x plus 3 times x plus 3. So you got here is 10x plus 9, and x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. So you got here is 10x plus 9 equals x squared plus 6x plus 9. You're going to bring this equation at 10x plus 9 onto this side. So you're going to subtract 10x and 9 on both sides. And what you got is 0 equals x squared minus 4x plus 0. Or you don't have to write 0. So what you got is x squared minus 4x. Now you're going to solve for the x value. So you're going to break this as x times x minus 4 and apply the zero product property. You got x equals 4 times x minus 4 equals 0. X equals 0, x equals 4. So these are the two x values. We're going to check one by one which one is our actual value by plugging it into the given equation. So first you're going to check x equals 0 into the given equation 10x plus 9 square root equals x plus 3 and plug it in 0. So you got here is 10 times 0 plus 9 equals 0 plus 3. So that's going to be square root of 9 equals 3. So which is 3 equals 3. That is true. Now we're going to check is x equals 4 into the given equation 10 times 4 plus 9 equals 4 plus 3. That's going to give us 40 plus 9 equals 4 plus 3. That's 49 equals 7. And in this case is 7 equals 7, which is true. In this case, both the answers are true. So x equals 0 and x equals 4 is your answer. Now you're going to try the number 5 and number 6 in your notebooks and solve and check your answers. Let's now match the answer for number 5 and number 6. For number 5, square on both sides, square root and square cancel. Here you're going to get x plus 3 square, which is the same thing, foiling this by itself, and you got x square plus 6x plus 9. Subtract 10x and negative 6, you got this equation, and you use the cross method, where on the top of the cross is 3, on the bottom is negative 4. The two factors you got is x minus 3, x minus 1 equals 0. You put them equal to 0 one by one, x equals 3 and 1. And you're going to check both the x values using the original equation and plug it in 3 first and plug it in 1. They both came out true, so the answer x equals 3 and x equals 1. The next is number 6, where you have to take square on both sides to get rid of the square root on both sides. You're going to get 2x plus 5 equals x plus 7. Subtract x on both sides and negative 5 on both sides. You got x equals 2. What you're going to plug it in into the given equation. So you got square root 9 equals square root 9. 3 equals 3 is true. So that is your right answer. X equals 2.